সো নাম্বার থিওরি নিয়ে আমরা এর আগে সেট থিওরির সাথেও একটু ডিসকাস করেছিলাম। সো আজকের সেশনে আমরা শুরুর পার্টে এই নাম্বারের ইভালুয়েশনটা আর ডিসকাস করছি না। আই এম স্টার্টিং অ্যাহেড অফ দ্যাট। সবার মনে আছে তো আমরা যেটা ডিসকাস করেছিলাম আগে, যে স্টার্টিং ফ্রম ন্যাচারাল নাম্বার, দেন প্রসিডিং টু হোল নাম্বার, integers, rational number, irrational number, how the number system has evolved from natural number system to real number system. Okay, আজকে আমরা স্টার্ট করব উইথ নোটিং ডেন্স প্রপার্টি অফ রিয়েল নাম্বারস. It is an idea that I have shared with you verbally earlier, but I think formal note কিছু লেখা হয়নি. So dense প্রপার্টিটা একটু সবাই নোট করে নেবে. Is it properly visible to all?
Yes, sir.
Yes, sir.
আমি একবার রিড আউটও করে দিচ্ছি তোমাদের জন্য. Dense property of real number says, on real number line, it does not matter how close we select two rational numbers, we can always find at least one irrational number between them. Also, on this number line, if you select two irrational numbers, doesn't matter how close you select them, we will always be able to find at least one rational number between them. Okay, based on that we had a discussion earlier, but it was not documented as your class note. So for today's session, start with documenting dense property of number line. How we are going to apply that, we will go for that in today's class, as well as few other ideas. So as long as you are writing, I am keeping the recording in pause, and once you are done, I'll resume.
Yes, sir.
Yes, sir.
Okay, so as all of you are done, আমরা এবার এটার application দেখবো. Application কিরকম? Like the first example we are going through, to find three rational numbers between √5 and √6. এবার যখন আমরা এই টাইপের কোশ্চেন করছি, √5 আর √6 এর মধ্যে তিনটে রেশনাল নাম্বার খোঁজা, definitely those who have good perception about numbers and their rough decimal representation, তারা তো খুব সহজেই আমরা এদের অ্যাপ্রক্সিমেট ভ্যালুগুলো ভাবতে পারি, অ্যান্ড ইন্টারমিডিয়েটলি তিনটে কেন, মোর দ্যান দ্যাট ভ্যালুও খুব সহজেই লিখতে পারি. But that's going to be a good approach for competitive purpose, MCQ পেপারে করলে that's okay. আমরা যদি এই কোশ্চেনটাই স্কুল বা বোর্ডের জন্য ভাবি, বা এনি পেপার where you have to write the subjective solution, তার জন্য যদি ভাবি, আমি আগেও তোমাদের বলেছিলাম subjective papers are not those ones where you have been asked whether you know the answer or not. Okay, it's not a query that can you answer it or not. Subjective papers means over there the question been given in the paper, can you describe the solution or not? So if we need to describe or establish three values between them, তার জন্য আমরা যে অ্যাপ্রোচটা নিই, যে বেসিক্যালি আমাদের দরকার কি, 5 and 6 they are not perfect square of any rational number, hence √5 and √6 are irrational. So আমাদের দরকার 5 আর 6 এর মধ্যে এমন numbers which are perfect squares of rational numbers, and that square value is between 5 and 6. But 5 আর 6 এর মধ্যে একটা rational number-এর perfect square খোঁজা তার থেকে সহজ হচ্ছে আমরা যদি আমাদের কনসিডারেশনটাকে একটু অন্যভাবে রাখি. কিভাবে আমরা রাখতে পারি, যে √5 না লিখে এটাকে যদি আমরা একটু স্কেল আপ করি, যেমন √5 এর জায়গায় যদি আমি √500/100 লিখি, আর √6 এর জায়গায় যদি √600/100 লিখি, তাহলে দেখো 500 থেকে 600 এর মধ্যে পারফেক্ট স্কোয়ার খুঁজতে পারলে আমাদের কাজটা হয়ে যায়. এবার তাহলে প্রথম কোয়েরি, যে এটা তো করবার জন্য রুটের ভেতরে 5x/x লিখলেই হয়, x could have been any number, হঠাৎ করে 100 মাল্টিপলি কেন? এই কোয়েরি কারোর আছে? যে যদি আমাদের স্কেল আপ করবারই লক্ষ্য হতো, তাহলে তো আমরা চাইলে √15/3 আর √18/3ও লিখতে পারতাম. সেরকমটা না লিখে হঠাৎ করে 100 মাল্টিপলি কেন? আনসার করেসপন্ডিং টু ইট ইজ যে অ্যাজ সাচ আমরা মাল্টিপ্লাই করব নিউমারেটর অ্যান্ড ডিনোমিনেটরে এমন একটা ভ্যালু হু শুড বি ইটসেলফ পারফেক্ট স্কোয়ার। কারণ এইভাবে আমরা স্কেলটাকে একটু বড় করে নিচ্ছি। √5 আর √6, 5 আর 6 কনসিকিউটিভ ন্যাচারাল নাম্বার ছিল, আমরা এদেরকে যেই রেশিও মোডে নিয়ে যাচ্ছি অ্যাজ পার ডিনোমিনেটর এদের মধ্যে ডিস্টেন্সটা একটু বেশি ভাবে দেখতে পাচ্ছি। সো স্কেল আপ করার একটা লক্ষ্য ছিল। সো সেই ডাইরেকশনে স্কেল আপ করবার সময় এনি পারফেক্ট স্কোয়ার মাল্টিপ্লিকেশন উইল ডু, because as soon as we are going to replace the numerator by some value between the existing numerators and as identified as a perfect square of some rational number, তখন স্কোয়ার রুটের বাইরে আনবার সময় ডিনোমিনেটরেরও তো স্কোয়ার রুট করতে হবে। So multiplication by a perfect square was essential. এবার পারফেক্ট স্কোয়ারই যদি টার্গেট হয় তাহলে 4, 9, 25, 36 এত কিছু ছেড়ে ডাইরেক্টলি 100 কেন? যে 100 কে যখন আমরা স্কোয়ার রুটের বাইরে আনবো ইট উইল বিকাম 10। এবার তোমরা আমাকে বলো, ডিভিশন যখন করতে হবে বাইরে এনে, যখন পুরো নাম্বারটাকে আমরা স্কোয়ার রুটের বাইরে এনে ফেলবো, ডিভিশন বাই এনি আদার নাম্বার আর ডিভিশন বাই 10 ইজিয়ার কোনটা হবে?
Division by 10.
ওকে, সো তাই জন্য আমরা রুটের ভেতরে 100 দিয়ে মাল্টিপ্লাই করলাম। বাই চান্স যদি কোনো এরকম কোশ্চেন হয় যেখানে 100 দিয়ে মাল্টিপ্লাই করেও আমরা যে রেঞ্জ পাচ্ছি, নিউমারেটর গুলোর যে রেঞ্জ পাচ্ছি, সেটা যদি প্রপারলি আমাদের আনসার দেওয়ার পক্ষে বা কনক্লুড করবার পক্ষে সাফিসিয়েন্ট না হয়, ইন দ্যাট কেস the next possible multiplication we will look forward to is multiplication by 10 to the power 4 বা 10,000 দিয়ে। কেন না 10,000 বা 10 to the power 4 ওটা স্কোয়ার রুটের বাইরে আসলে 100 হবে, আর স্কেল আপটাও অনেক বেশি হয়ে যাবে। তাহলে 500 আর 600 না লিখে তখন আমরা নিউমারেটর গুলোকে 50,000 আর 60,000 করে দেব, আর ডিনোমিনেটর গুলো তখন থাকবে স্কোয়ার অফ 100। ওকে, এবার যেহেতু 500 থেকে 600 এমন একটা রেঞ্জ যার মধ্যে ন্যাচারাল নাম্বারের স্কোয়ার খোঁজাটা রেসপেক্টিভলি ইজিয়ার জব অ্যান্ড উই ক্যান অলসো গেট ইট কমফোর্টেবলি, তাই এখানে আমাদের সেরকম দরকারও নেই, আমরা করছিও না। ওকে, সো যেই এরকম লিখলাম তারপরে আমাদের কাজ কি, যে এমন তিনটে এক্স ওয়াই আর জেড খুঁজে বার করা যারা 500 থেকে 600 এর মধ্যে and they are squares of some rational number. Without loss of genuinity আমরা ধরে নিতে পারি যে যাদেরকে খুঁজবো তাদের মধ্যে সব থেকে ছোটটাকে আমরা x বলছি, the intermediate one been addressed as y and the largest one addressed as z. So at this moment our targets are perfect squares of rational numbers more than 500, less than 600. Now tell me what we are good at. To find perfect squares of rational number or perfect square of natural number. কোনটা আমরা বেশি সহজে খুঁজতে পারি? ন্যাচারাল নাম্বার। তাহলে আমাকে বলো এরকম কোন কোন পারফেক্ট স্কোয়ার পাচ্ছ? দোজ হু আর স্কোয়ারস অফ ন্যাচারাল নাম্বার and more than 500, less than 600.
Sir, 23 square,
23 square,
24
Very
square.
good.
24 square, 576.
Very good. The immediate larger than 500, a perfect square of natural number is 529, a square of 23, and the next one is 576, that square of 24.
Yes.
এবার যদি 23 এর স্কোয়ার আর 24 এর স্কোয়ার এই দুটো নাম্বারের মাঝে আসে 500 আর 600, তাহলে 23 আর 24 এর অ্যাভারেজের স্কোয়ার সেটাও এদের মাঝে চলে আসবে, রাইট? সো অ্যাকর্ডিংলি আমরা দেখলাম যে নিউমারেটর গুলোর জন্য আমাদের কাছে চয়েস হতে পারে 23 এর স্কোয়ার, 23.5 এর স্কোয়ার, 24 এর স্কোয়ার। They all will fall between 500 and 600. Okay, and hence can a possible replacement to the numerator to make it appear as a rational number between √5 and √6. এদেরকে যখন রুটের বাইরে বার করব 23 এর স্কোয়ার বা 529 নিউমারেটর থেকে তো 23 আসবে, আর ডিনোমিনেটরের 100 এর জন্য 10. So this one will provide us 23/10 outside the square root. এখান থেকে 23.5/10, এখান থেকে 24/10, and hence 2.3, 2.35, 2.4. These are identified rational numbers between √5 and √6. As such, যখন আমরা 23 এর স্কোয়ার আর 24 এর স্কোয়ার এদের দুজনের মাঝখানে খুঁজে পেয়ে গেছি 500 আর 600 এর মাঝখানে, so you have already got a interval starting from 2.3 and going up to 2.4, মানে ক্লোজ ইন্টারভাল 2.3 থেকে 2.4, এই পুরো স্ট্রেচটাই আমাদের কাছে চলে আসবে. So not just these three, তুমি তোমার ইচ্ছে মতন any rational number from that close interval সেটাকে সিলেক্ট করতে পারো. Even as you can find 23 square was 529. So even if you consider some rational number very close to 2.3 but a bit less than 2.3, they will also be acceptable. Similarly, 24 square 576 is much less than 600. So if you wish to write a rational number just more than 2.4 but very close to 2.4, that will also do the job. But establishment purposes, the rational numbers that you have concluded, তাদের মাঝ থেকেই থার্ড ইনস্ট্যান্সটা ক্রিয়েট করা বেটার. ওকে? Is it okay to all?
Yes, sir.
সবাই সলিউশন ফলো করেছো?
Yes, sir.
ওকে. সলিউশনের প্রথম দুটো লাইন কি সবার লেখা হয়ে গেছে?
Yes, sir.
ওকে. সো যদি প্রথম দুটো লাইন লেখা হয়ে থাকে, can I scroll up to this? ওকে. আচ্ছা, এখান থেকে দেখো, এই কোশ্চেনের জন্য আমরা অল্টারনেট অ্যাপ্রোচ হিসেবে এরকমও কি বলতে পারতাম যে √5 that is √180 বা আচ্ছা না 20 জন্য হবে না, এটাও বলতে পারতাম. Is that okay? আমি জাস্ট একটা ইনস্ট্যান্স হিসেবে দেখাচ্ছি that if I do not go for multiplying 100 to numerator and denominator, তাতে আমাদের কাছে চয়েস কি আসছে, এদের মাঝখানে আমি √49/9 এটাও লিখতে পারি. Right?
দেখা যাচ্ছে না।
Just a moment. Is it accessible now?
No, sir.
Yes, sir. No.
Okay. Just have a look to this transition, though I have already written, this screen is lagging a bit.
See it.
So I have gone for the transition where √5 and √6, instead of multiplying by 100, I have replaced them as their ninth multiple. So √45/9 and √54/9. Now when 45/9 and 54/9 are two such numbers, we can have a perfect square between 45 and 54. right? Can you answer me which is that?
49.
49. Very good. So intermediately we can have 49 by 9. Root over 49 by 9 এটাকে আর কি লিখতে পারি?
7/3.
7/3.
7 by 3. 7 by 3 তার মানে roughly the representation is 2.333 and continues, or you can say 2.3 bar. Okay, if it is so, you can have something very close rational numbers terminating decimals and can assess your result from there. Okay, যে অলরেডি যেহেতু আমরা 2.3 বার পাচ্ছি, so 2.334, 2.335 or anything like that, that can also do the job. But obviously এখানে 3 দিয়ে ডিভিশন করতে হচ্ছে। আমরা যেভাবে নিয়েছিলাম সেটাতে আমাদের জন্য ডিভিশনটা খুব সহজ ছিল। Divisions by 10 or powers of 10, they can only shift the decimal point towards left. 1 এর পরে যতগুলো 0 থাকবে in your divisor, the decimal point will be shifted towards left by that many position. So এই আইডিয়া দিয়েই আমাদের কাজ হয়ে যায়। Is it clear? So this is an alternate choice, but usually এই choice গুলোর থেকে multiplication by 100 is going to work better. Okay? Okay, is the next question visible? Now all of you have to answer this question, sticking to the same method. সবার ক্লিয়ার অ্যাপ্রোচটা? আনসারটা 25 মান বললে তো?
Yes, sir.
25 মান যেটা বলেছে সবাই ফলো করতে পেরেছো?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes.
তো ইকুইভ্যালেন্টলি আমরা আবারও √22 আর √23 না ভেবে এদেরকে রুটের ভেতরে 2200 by 100 and রুটের ভেতরে 2300 by 100 ভাবতে পারি। Now 2200 আর 2300 এর মধ্যে একটাই পারফেক্ট স্কোয়ার আসছে, that's 47 square, which is 2209, very close to 2200. 48 square is marginally over 2300, that's 2304. Okay, so তার মানে 47 square by 10 square, that is there between √22 and √23, and it is sufficiently close to √22. So 4.7 এর থেকে একটু greater যে value গুলো, not going much close to 4.8, they can be comfortably concluded between √22 and √23. So সবসময় যে আমরা দুটো decisive rational number পাবো, like the last question, it's not necessary. But even if we get one and make very small changes, like তুমি decimal places এ যত ডিপ যাবে, মানে decimal এর পর যতগুলো রুম ছেড়ে তারপর তুমি চেঞ্জেস করবে, it will be that less of a change, and hence the values of their squares are supposed to be within the considered range. এখানে ইভেন আমি যেরকম 4.7 এর পর 4.701, 702 লিখেছি, অতটা না করে আমরা যদি 4.71, 4.72, 4.73 এগুলোও করি, that's not going to be an issue, because we know 4.8 is going to be √23.04. So we can go quite close to 4.8, but not much close to it. √23 এর মধ্যে রাখবার জন্য 4.77 পর্যন্ত it's comfortable. 4.78, 4.79, that is so close, we need not to take that much of risk. তার থেকে hassle free হচ্ছে, if you do have any concern, make changes in the next or next to next decimal position. In that case, you are going to get it as a rational number because of terminating decimal, and the values are also within range comfortably. Am I clear to all? সবাই এটা ফলো করতে পেরেছি? So ইনসারশনের প্রবলেম নিয়ে কোনো অসুবিধা আছে? ইনসারশনের আইডিয়াটা ক্লিয়ার? This type of problems are called insertion. এবং এখানে √22 আর √23 বলে না, you can be offered with far more close to irrational number, and we can still have rational numbers between them. এখানে কখনো আমাদের অসুবিধা হবে due to given irrational numbers being close. যদি খুব close value দেয়, we can multiply them with higher powers of 10, or to be more precise, higher even powers of 10. আপাতত আমরা 100 দিয়ে নিউমারেটর ডিনোমিনেটরকে মাল্টিপ্লাই করে আমাদের যে রিকোয়ারমেন্ট সেটা স্যাটিসফাই করতে পারছি। If somehow that does not stand sufficient, আমরা এরপর 10 to the power 4 মানে 10,000 দিয়ে মাল্টিপ্লাই করতে পারি। If that is also not sufficient, 10 to the power 6, 10 to the power 8, and any higher even power of 10 দিয়ে মাল্টিপ্লাই করেও আমরা আমাদের টার্গেটকে ফুলফিল করতে পারি। Is it okay to all? The next ideas are co-prime numbers. So just have a note of this section. So is the idea of co-prime numbers and pairwise co-prime numbers clear? We consider a collection of natural numbers co-prime when their HCF is 1. Okay? It's not necessary in that case from that collection you select any two, they are also going to give you HCF 1. It may or may not be true, but for addressing a collection of natural numbers co-prime, it is sufficient to have their HCF 1. Like you can have the first example. Over here, the numbers we have considered is 2, 4, 6, 8, 11. Overall, if we consider them, their HCF is 1. But there are pairs like 2, 4. Their HCF will be 2. There will be 4 and 8, where the HCF is 4. And so many other pairs where they are not co-prime. But if you look to the second example from here, 5, 8, 9, 11, 23, you consider any pair that may be 5 and 9, that may be 9 and 11, that may be 5 and 23. Whatever we consider, every pair is co-prime. When we are considering a collection of co-prime numbers, or the numbers are co-prime, both of them are acceptable. But out of that, the second example where any selection of a pair of natural numbers is also appearing co-prime, only that variations are to be addressed as pairwise co-prime numbers. Does that make sense to everyone?
Yes, sir.
সবাই ফলো করেছি?
Yes, sir.
Okay. Should I scroll a bit more? The next part is also something we have discussed earlier. Any rational number that can be represented in integer by integer mode, but that's not unique. Okay, like the rational number 0.5, that could have been written as 3 by 6, 5 by 10, 17 by 34, 63 by 126. So many ways to get it represented. But to have a unique fractional representation for all the rational number, we can get to the P by Q form, where numerator P and denominator Q are two co-prime integers. That's also called the reduced form. So once we come into the fractional representation for any rational number, there are infinitely many variations of writing the same rational number. For the uniqueness of the representation, we can get them represented in the reduced form. And how we can identify that it is the reduced form? So that identifying mark is when we can get to an integer by integer mode, where the numerator and denominator having co-prime integers, that's the unique and the reduced representation for the rational number. For irrational numbers, we cannot represent them in P by Q form. Next, write down rational numbers or surds. Now, rational numbers or surds, these are such irrational numbers which can be represented as a rational number applied with a rational power. Okay. So an irrational number, which is a rational power result of a rational number, is called radical or surd. Okay. So for radical or surd, you should believe it is such an irrational number which can always be represented as a base rational number applied with a power rational number, but the final result is not rational. Okay. If it is so, we can call such an irrational number surd or radical. Like the examples you can have over here. Is it okay to all?
Yes, sir.
So can we call all irrational numbers as surd or radical?
Yes, sir.
I'm repeating the question once more.
Sir,
Can
pi,
I call every irrational number a surd or radical?
no, sir, because pi and they are also rational number,
They are
irrational, but they are non-surds.
Very good. So apart from surd, there is another variation of irrational numbers where the number is irrational, but we cannot write them as ratio of two, or sorry, we cannot represent them as rational power of some rational number. Like we already know, there is the constant ratio of the circumference length and diameter length for any circle, okay, or the electron emission rate of radioactive substances that follows a particular exponential behavior with an irrational constant base. These irrational numbers are something that cannot be represented as rational number with rational power. Such irrational numbers are called transcendental numbers. Okay? Like pi, like Euler number E, or even if I consider root 2 to the power root 3, these are also irrational numbers, but we cannot get them represented in the form of a rational number with a rational power, generating a value which is irrational. Okay? Is it clear to all? কারোর কিছু
বুঝিয়ে
প্রশ্ন
দেবেন?
রয়েছে? হ্যাঁ, অর্চিষা কোন পার্টটা ফলো করতে পারোনি বলো?
স্যার এই সার্ডস এর মানে এই সার্ডস এর ডেফিনেশনটা আরেকবার বুঝিয়ে দেবেন?
Surd বলছে if we have a rational number applied with a rational power, but due to this exponential value or due to this exponential representation, the final value is not anymore rational, তাহলে যে irrational রেজাল্টটা পাবে তাকে তুমি বলবে radical বা surd.
যেমন
Clear?
ইয়েস স্যার। স্যার এই এক্সাম্পলটা দিয়ে একবার বুঝিয়ে দেবেন, ফার্স্ট এক্সাম্পলটা দিয়ে।
যেমন √6 মানে 6 এর কোন পাওয়ার? স্কোয়ার রুট অফ 6, এটাকে 6 এর পাওয়ার হিসেবে লেখা যায়?
স্যার হাফ।
তাহলে 6 is a rational number, half is a rational number,
ইয়েস স্যার।
6 to the power half, তাহলে rational to the power rational, কিন্তু ফাইনাল ভ্যালুটা কি আর rational থাকলো?
নো স্যার।
সো এই যে রেজাল্টটা পেলাম irrational number as a result of applying a rational number in the power of another rational number, that type of irrational numbers are called surd.
ওকে
So if you can do so, it is surd. If you are getting irrational number which are not surd, then definitely they are transcendental numbers. So the whole collection of irrational numbers been divided into two groups. Like the whole collection of real numbers, তাদেরকেও আমরা দুটো গ্রুপে ডিভাইড করেছিলাম, rational or irrational. আমরা জানি every rational number is real, but that does not guarantee all real numbers are rational. সেরকমই দেখো irrational numbersদেরকে আবার দুটো গ্রুপে ডিভাইড করা হয়েছে, where it is surd or transcendental.
Okay, sir.
So every
Thank you.
surd is irrational, but not all irrational are surd. Okay?
Okay, sir. Thank you,
sir,
sir.
radical or surd যে লাস্ট এক্সাম্পলটা আছে ওখানে মানে ট্রিপল ইকুয়ালস টু সাইনটা কেন দেওয়া আছে?
সরি,
স্যার র্যাডিক্যাল আর সার্ডের যে লাস্ট এক্সাম্পলটা আছে ওখানে ইকুয়ালস টু সাইন না দিয়ে ওখানে ওই তিনটে মার্ক কেন
that
করা
is
আছে?
basically equivalent sign. Okay, both are going to mean the same for the numbers. Equal লিখলেও ঠিক, equivalent বললেও ঠিক. Okay,
আচ্ছা,
so as such you can write equal, no problem with that. For numbers, equal and equivalent means the same thing. সবার ক্লিয়ার এই পর্যন্ত? Should I scroll a bit?
Yes, sir.
স্যার ট্রান্সেন্ডেন্টাল নাম্বারের লাস্ট এক্সাম্পলটা একবার বোঝাবেন?
হ্যাঁ, √2 তার পাওয়ারে √3 লেখা আছে। So that's an irrational number, but you cannot represent it as a rational number appearing with a rational power, তাই না? তুমি খুব বেশি হলে কি করতে পারো, এটাকে 2 to the power √3/2 লিখতে পারো, তাই না? So we cannot represent this value as rational number with rational power, তাই জন্য এটা সর্ট না। So transcendental number and its examples, can I scroll up to that?
Yes, sir.
সবার এই পর্যন্ত লেখা হয়ে গেছে তো, এই √2 to the power √3?
Yes, sir.
Yes, sir.
Okay, so just get this next part noted. So as we have gone through this part, the next idea is LCM and HCF of rational numbers. If we do have n number of rational values been represented as a1 by b1, a2 by b2, so on, up to an by bn, then while having their LCM, we should go for LCM of the numerators divided by HCF of the denominators. I believe we have discussed that in the class last time when I have shown you that for any rational number, if we try to have a natural multiple, there are two choices. Either we can multiply the numerator with a natural number, or we may divide the denominator by a natural number. Both these transformations will provide us a natural multiple of the considered fraction. So when we are considering n number of fractions, for them, if we need to have a common natural multiple, we need the common natural multiples of the numerator and common factor of the denominator. So if we keep the numerator's common natural multiple to its least possibility and replace the denominator's common factors to its highest possibility, in that case, this single fractional number we reach is natural multiple of all the considered fraction and least from the lot. And with similar idea, the HCF of the fractions can be represented as HCF of the numerators divided by LCM of the denominators. Are these two ideas clear to all?
So can you explain the conjugate irrational number once? যেটা আগে দেখানো লিখলাম যেটা আগে।
Conjugate irrational number, the idea is corresponding to any irrational number, if you can find another irrational number such that their sum and product both are always rational, then such two irrational numbers are called conjugate pairs. Okay? Like if x is an irrational number, y is another irrational number, such that x plus y as well as x into y are both rational values, then x and y are going to be addressed as conjugate irrational numbers. For example, I have given you a particular format. Okay, if p and q are both rational, like you can find over here, If P and Q are both rational and Q is not a perfect square of any rational number, then root Q is irrational.
Yes, sir.
If root Q is irrational, then P added to it or root Q subtracted from P both will be irrational.
Yes, sir.
But if you consider P plus root Q and P minus root Q, their addition will always be 2P.
2P.
P being rational, 2P is always rational,
Yes.
right? And
Yes,
if you multiply these two terms, P plus root Q and P minus root Q, that is going to give you P square minus Q.
yes, sir.
That is also rational.
Yes.
So for every rational number which can be represented in P plus root Q and P minus root Q, for rational values of P and Q, they are always conjugate pair.
Okay, sir.
That's one of the many possibilities. It's not the only possibility. Okay. Are you all comfortable with the idea of LCM and HCF?
Yes,
Is it
sir.
visible?
Yes, sir.
Kindly explain with an example the LCM.
Sorry?
You kindly show us an example of the LCM one.
Yeah, definitely. I'll go for the idea. Like consider 2 by 5. Okay. And consider 1 by 4. Now 2 by 5 and 1 by 4, these are two fractional numbers. So if you need to have LCM of these two numbers, the numerators are 2 and 1. LCM will remain 2. The denominators are 4 and 5. Their HCF will be 1. So that confirms 2, which is fifth multiple of 2 by 5, and eighth multiple of 1 by 4 is the least common natural multiple. Okay? Everyone just have a note of this same part. Okay. Are you all comfortable with this information? Can anyone justify what will happen if the numbers are of opposite sign? If x and y are of opposite sign, what about the LCM then? Anyone?
Sir, will it be
Hello?
negative?
No. As I discussed earlier, LCM means
LCM will be
least
smaller than
common
one of x.
natural multiple, right? Yes, Orchishman?
I was saying LCM will be smaller than one of the numbers which is like
No. So listen again carefully. LCM means least common natural multiple. Now, if x and y are of opposite sign, say for the instance, we are considering x is a negative number, y is a positive number. If x is negative, then how are the natural multiples of x? Positive or negative?
The positive.
If x is negative, then natural multiples will be? Yes, Priyank?
Negative.
Negative.
Negative. Are you convinced? Anyone having a confusion? If x is a negative number, then its natural multiples will remain negative. But if y is a positive number, then its natural multiples will be what type of number? Positive or negative?
Positive.
Positive.
So if x and y are of opposite sign, can they have a natural multiple which is common to both?
Sir. No, sir.
As one of them having their natural multiples appearing only as negative values, while the other will have its natural multiples appearing only as positive values. Can they ever have a common multiple?
No, sir.
So if x and y are of opposite sign, then the idea of LCM fails. Like it fails over LCM of rational and irrational numbers. We cannot have a common natural multiple for a rational number and an irrational number. Even if you have two irrational numbers of different variation, means the two numbers are not irrational because of the same expression, like root 2 and root 3. They are also unable to have the LCM. Okay, even their natural multiples will never be common. But if you have two irrational numbers, which is irrational because of same part and it is rational multiple of them, like 3 root 3 and 4 root 3, we can have LCM for them as 12 root 3. Okay, but even root 2 and root 3, different type of irrational numbers, they cannot have LCM. A rational number and an irrational number, they cannot have LCM. Okay, a positive number and a negative number, they cannot have LCM, because while saying LCM, we say least common multiple, but as we have discussed earlier, what we actually mean is least common natural multiple. Is that right? Acceptable for all?
Yes.
Yes.
Sir.
Okay. So now we will try to have rationalizing the denominator type problems. For the first one, I am showing you, like over here, as you can find, there is one fraction given with numerator 8 and denominator is an irrational number marked as root 15 plus 1 minus root 5 minus root 3. Now, our aim is to make the denominator a rational number, and to do so, we should multiply same factor to the numerator and denominator. We can pursue this process by multiplying same factors to the numerator and denominator. Nowhere it's been asked that you should multiply something so that the ratio is becoming rational number. So whatever is changes happening to the numerator, we are least bothered about that. All our motive is towards making the denominator rational by multiplying same factor to the numerator and denominator. So in order to do that, we have found that in the denominator, we do have irrational terms of 3 variation. Out of that, the 2 positive terms and the 2 negative terms, if we consider them pairwise, okay, like root 15 plus 1 was the positive pair, and if you take a minus common of the rest, then other 2 is going to be another pair, where we will be having a subtraction getting performed between the pairs. Now, if I multiply this factor with another factor where we do have same 2 pairs, like this 2 pair were getting subtracted, if I multiply them with a factor where the same 2 pairs this time getting added, so the multiplication will lead us to a square minus b square type transition, where the first square will be for root 15 plus 1 and the second square will be for root 5 plus root 3. And as we are performing subtraction of these 2 perfect square, so final result is going to be free from any kind of radicals, and it's been found to be 8. Okay, so it guarantees that if we multiply this particular factor to the numerator and denominator both, the denominator after the multiplication will get transformed to the 8, which is a rational number. So that will confirm the rationalization process done. Now for simplification purpose, you can cancel the 8 that you have found after the multiplication from denominator with the pre-existing 8 of numerator. So after the multiplication, I can have this ratio getting simplified only to the number appearing within the red box. Okay, so this can be one of the approaches. Whereas there is another approach, like if I
Sir, the
write,
answer will be 1.
sorry,
The answer will be 1.
no, not 1. The answer will be root 15 plus 1 plus root 5 plus root 3.
So we have to multiply that as well with 8.
Yes, sir. If you multiply just a factor to the denominator, will the ratio be the same
No,
anymore?
no. We need to multiply it with
Whatever you are multiplying to the denominator, you should multiply that to the numerator.
Yes, sir.
Now over here, the denominator we had was something special and is something that you can look forward to factorize. We may write the factors in this way. What you can transform, you can take a root 5 common of the first two term, which is giving you root 3 minus 1. And you can take a minus 1 common of the last two term, which will give you again root 3 minus 1. Okay? Hence, you can factorize the denominator as root 5 minus 1 multiplied with another factor root 3 minus 1. Is it okay? Now, can you tell me our rationalizing factor for root 5 minus 1?
Root 5
Only
plus
for root 5.
root.
Root 5 plus 1 will do the job. Can I call it conjugate irrational number?
Yes, sir.
Yes, sir.
Do all of you agree? তোমরা কি এগ্রি করছো root 5 minus 1 এর কনজুগেট কে কি root 5 plus 1 বলা যায়?
Yes, sir.
Yes, sir.
Yes, sir.
What was the criteria of calling a irrational number conjugate?
Sir, it won't be
Sir, it has to
conjugate
make a
because
rational sum or rational multiply.
Very good. But root 5 minus 1 and root 5 plus 1, what is their sum?
so it's coming to root 5. That is
Root 5.
So 2 root 5.
Very good. So can it be marked as conjugate?
No, sir.
No, sir.
Can it be called rationalizing factor?
Yes, sir.
Because after the multiplication, product is rational, so it can be addressed as rationalizing factor, but we can't mark that as conjugate irrational. So what will be conjugate irrational of root 5 minus 1? Can anyone answer?
Sir, root 5 plus 1?
Just now we have gone through, it's not conjugate. Orchisha, match করছে?
No, sir.
Add করলে irrational পাচ্ছো তো?
Yes,
So
sir.
can anyone answer what will be conjugate of root 5 minus 1?
Sir,
হ্যাঁ
4
বলো।
root 5 plus 1 হবে।
Sorry?
4 root 5 plus 1.
Conjugate?
হ্যাঁ।
Add করে দেখো তো।
1 minus root 5.
Not 1 minus root 5, it will be minus 1 minus root 5. Okay? If you go for 1 minus root 5, the product will not be rational. Okay? So firstly, you should change the number into the mode. It can be represented as minus 1 plus root 5. Now is it matching with p plus root q form? Once I write it as minus 1 plus root 5. So what will be conjugate irrational number? Hello?
Minus 1 minus root 5.
Minus 1 minus root 5. Is it conclusive? Anyway, we were not finding the conjugate, but our aim was rationalizing factor. And for rationalizing factor, root 5 minus 1 definitely can have root 5 plus 1 as a rationalizing factor. The sum is not rational, but the product is, and that's sufficient to call a factor rationalizing factor. So corresponding to root 5 minus 1, if I have a multiplication with root 5 plus 1, and corresponding to root 3 minus 1, if I have a multiplication by rationalizing factor root 3 plus 1, this will definitely fulfill our required job. Now, if we multiply root 5 plus 1 with root 3 plus 1, you can identify it is exactly this expression that we have gone through. Right? So, as the denominator was factorizable, so over here it doesn't matter in which way you proceed, we are going to get the same transformation or same transformed value after we make the denominator a rational number. Is it okay to all?
Yes, sir.
Yes, sir.
সবার ক্লিয়ার এটা? কনজুগেটটা বলবার সময় কিন্তু খেয়াল রাখবে, কনজুগেটের সময় অনেকেই ভুল বললে। ওকে, rationalizing factor doesn't have much criteria. It is simply a factor which should be multiplied with your existing irrational number in order to give you a product which is rational. But when you are saying conjugate irrational, it's not just going to give you product value rational, but also sum value rational. So before concluding, try to get it transformed into p plus root q or p minus root q form. In that case, concluding the conjugate will be easier, provided it is feasible to be getting represented in p plus root q form. For the time being, we are going for this second example. Over here, can you all observe the second question?
No, sir.
No, sir.
Okay. Is it visible now?
Yes, sir.
Yes, sir. Yes, sir.
Yes. So we have been given with a number 2 plus root 3 plus root 5. You need to rationalize this. That means you need to find the rationalizing factor or maybe the rationalizing factors that should be multiplied with it in order to get the product finally transformed into a rational value. Okay? Now, as we do have two different type of irrational, over here a single factor will not be useful to get it completely transformed into rational number after first multiplication. So you should try to get it step by step. Firstly you should try, then I'll discuss. So সবাই একবার try করে নাও. So just now I have got the response from Shiyadita. Was that acceptable for all? সবাই follow করতে পেরেছো? Shiyadita যেটা বললো? Though I have shown here with a different approach, I have considered 2 plus root 3 together and root 5 separately and addressed it accordingly 2 plus root 3 minus root 5 as the first factor to multiply. This is something we must go for কারণ initially square root remove করবার একমাত্র উপায় squaring. And the easiest approach আমাদের কাছে যে ফর্মটা আছে, if I consider it in a plus b form, then multiplying with a minus b will provide us the product as a square minus b square. Individual irrational term which is appearing with a square root, তার যদি আমরা square করতে পারি, we will get it rationalized. So with that motive we initiated, and after performing the multiplication with 2 plus root 3 minus root 5, we have got 2 plus root 3 whole square minus square of root 5. Eventually that gets into 4 plus 3 plus 4 root 3 minus 5, which is 2 plus 4 root 3. So we multiplied a factor, but the final product haven't become rational. 2 plus 4 root 3 is still irrational. Can we take something common out of 2 plus 4 root 3?
Sir,
We can take 2 common.
2 common.
2 common নিলে পড়ে থাকছে 1 plus 2 root 3. Now 2 plus 4 root 3 is irrational because of 2 or because of 1 plus 2 root 3?
One
The
plus
1 plus
two.
2 3.
1 plus 2 root 3. So if I now plan for another factor which should get multiplied with 1 plus 2 root 3 and transform this into a rational number, then definitely our motive will be justified. Okay?
Yes.
And accordingly, we multiplied 1 minus 2 root 3 and hence the product reduced into a rational value. Is it okay?
Sir,
So
I
if
got
we
this
have
answer only.
so our final answer
Sir, can you
will
explain
be
this again?
yes. Which portion, Apratim?
The last part, like this, the purple part from where it starts.
Is the approach clear? What we are intending to achieve?
Yes, sir.
So with that particular motive, we have gone for firstly going for a factor that can be multiplied with 2 plus root 3 plus root 5 and can be reduced into an a square minus b square form to get the square root of from one of the irrational. So with that motive, is the first factor justified?
Yes, sir.
But the product we achieved through this multiplication, is it rational?
No, sir.
So as it is still irrational, it still requires further multiplication to become rational.
Yes, sir.
And the product you have achieved can also be factorized as rational number 2 multiplied with irrational number 1 plus 2 root 3,
Yes, sir.
right? So if we try to transform this value into something rational, we need to multiply by the rationalizing factor of the existing irrational 1 plus 2 root 3.
Okay, sir.
And accordingly we decided to go for 1 minus 2 root 3.
Yes, sir.
Eventually that takes the product to minus 22. So what rational number we will finally achieve, that will differ. Like if you go by the Sriyadita's approach, which was also perfect, but finally reaching the rational number minus 24, right Sriyadita?
Yes, sir.
Okay. But in my approach, we have finally reached minus 22. Anyway, that does not make one of these two process right and the other one wrong. Both are acceptable. And what rational number we will reach, it doesn't matter. The final conclusion that the rationalized value, what we are saying, and in order to get that product, what we are going to address as rationalizing factors. It's not anymore the rationalizing factor. It is rationalizing factors because it's not a single factor which has transformed 2 plus root 3 plus root 5 into something rational. It's a combination of two factors which on a successive multiplication transform this value into something rational.
Okay, sir.
Is
Thank you,
it
sir.
clear? Has everyone followed? Any problem this far?
Sir,
Excuse
Priyansh
sir,
bolo.
yes, sir. So till we reach a rational number, we have to continue using the identities and like
Can you repeat
multiplying.
once more?
Sir, like till we reach a rational number, we have to continue multiplying and getting identities.
The multiplication is the only way to reach that form. We do not consider adding or simply just removing the rational part as a process, because if it would have been a ratio where this written number 2 plus root 3 plus root 5 was either numerator and denominator, in order to get it changed into a rational number, multiplication is something which can be done in balance. Like if you have a by b, okay, it's yet to appear on the screen. It's lagging a bit. Just a moment. Okay, Priyans, you can even go verbally. Like if we do have a ratio A by B, then AX by BX is same fraction, right? But should I say A plus X divided by B plus X as the same fraction?
No, sir.
So it's not, right? So that's why multiplication is always a good idea in order to get it rationalized.
Okay, sir.
Is
Thank you,
that
sir.
clear?
এক্সকিউজ মি
Yes, sir.
স্যার
হ্যাঁ, অর্চিষা বলো।
স্যার আই হ্যাভ আমার ডাউট আছে একটা, মানে আগে আগে পড়ানো টপিক থেকে। স্যার পাই কি করে একটা ট্রান্সেন্ডেন্টাল নাম্বার হচ্ছে, আরেকবার কি বলে দেবেন?
হ্যাঁ, পাইকে তুমি কি একটা রেশনাল নাম্বারের রেশনাল পাওয়ার হিসেবে লিখতে পারবে?
নো স্যার।
তাই জন্যই ট্রান্সেন্ডেন্টাল নাম্বার। যদি লিখতে পারতে তাহলে কি হতো?
সার্ড হয়ে যেত।
ভেরি গুড।
কিন্তু স্যার আমরা ওকে 22/7 তো লিখতে পারি।
কেন বলো?
স্যার বিকজ পায়ের ভ্যালু তো 22/7
Is it?
অ্যাপ্রক্সিমেটলি।
Are we talking about approximations? সে তো অ্যাপ্রক্সিমেট করলে প্রত্যেকটা ইরেশনাল নাম্বার ইরেশনাল হয়ে যাবে। There will always be a rational number which is very close. Even আজকের আমরা ক্লাস নোট নেওয়াই শুরু করেছি ডেন্স প্রপার্টি দিয়ে, তাই না?
ইয়েস স্যার।
So
ওকে স্যার।
if we take two irrational number very close, there is always existing a rational number between them. On an approximate note, you can consider both this irrational number equaling that rational. তার মানে কি তারা rational হয়ে গেল?
নো স্যার। ওকে স্যার, আন্ডারস্টুড।
Okay.
থ্যাংক ইউ স্যার।
Is it okay to all? সবাই ফলো করতে পারছে এই পর্যন্ত?
Yes.
Yes, sir.
Yes, sir.
হ্যাঁ, বলো। Anyone asking something? Can you identify A and B if 3 plus 2 root 2 divided by 3 minus root 2 been represented as A plus B into root 2? Already it has been said A and B are rational numbers.